Hey everybody, welcome to this week's SQL training. I hope you won't mind that we're doing it through a video online sort of this week. I know some of you like recordings anyway, so I guess this will sort of get you that. But life happens, and so I just wanted to make sure that we still got our training on this week rather than canceling it or pushing it back again. And I'm really excited about this topic. In the next couple of weeks, we'll get started. But let's go ahead and get started. Thanks. All right, so today we are talking about temporary things. Let's go ahead and get started. Usual disclaimers and stuff, and your usual reminder. If you haven't been playing around in the Johnny 5 database, please do so. It's also a great place if you have questions. That's probably where I'm going to be like, hey, pull that up, and let's work through something there so that we've got a common ground that we can both get access to and try out with, okay? All right, so here is our lesson plan that we've been doing and going to be doing. We're most of the way there. We've only got a couple of classes left, so if you're excited for the end, it's in sight. If you're not, then well, all your cohorts probably think you're crazy. But we've talked about queries. We spent a good long while talking about tables and data structures and data types, that sort of stuff. Last week, we talked about built-in functions within SQL and other tools you can use for reporting and stuff like that. And today, we're talking about things that don't stick around. We're talking about temporary things. And what do I mean by that? Well, it is these sorts of things, right? We're talking about variables. And then with that, we're also going to talk about different types of tables that we haven't talked about already. We could also talk about queries, especially around subqueries and views. We're going to hold off on that a little bit. For right now, we're going to focus on those that I've got highlighted here, the variables and the tables, okay? Just because I think I'll lose your attention if we dive too far into the other thing and we go too long on this video. All right, so variables. What are variables? Well, I mean, we've all had variables probably in math class, right? When we were in elementary, probably late elementary school through high school and college, X equals something, and then you can use X in different places, right? Exact same thing here, but basically a variable is temporary storage in the computer. We're allocating somewhere in the memory of this computer for, hey, we're going to store something here. I'm giving a box, we're giving that box a name, and then eventually we're going to fill that box with something. It might be an integer, a number, it might be a string, right? It might be a date and time or other things, all right? In SQL, we create a variable first by using the declare statement, and then we can assign that variable a value using the set or select statements, okay? It doesn't make a lot of sense here on this slide. I'm just introducing you into the words. We will most definitely see those lots in the rest of this presentation, so you'll get very accustomed to them, okay? All right, the scope and the existence of a variable is that it only lives while the script that you're running is running, right? So if you run a script where you run something and then you try to run another script, even if you're in the same session, it doesn't have access to the variables you did in your other one because they don't exist anymore, all right? So it's really just within the code that you're running, within, or if you're doing a stored procedure or a user-defined function or something, then it's within the scope of that procedure or function, all right? Okay. Where might you use variables? Well, I mean, honestly, they're used all over the place. If you've had any exposure to programming at all, you know that variables are sort of an integral foundational block of programming. It's really no different for SQL when you start getting into doing more than just basic select statements, right? They're all over the place. And they're great for storing values for while the query is running, to doing some little intermediate calculations that maybe you don't want to have built into a whole select statement or something, right? You can do other steps. You can also use the variables to control the flow of things in your SQL in the same way that you can with other programming languages, right? If my total sales is greater than $3,000, then maybe I want to do this block of code that does something but maybe if it's not within that if statement, you want to do something else. You want to return an error, or you want to return different values or something, right? Exact same thing. You can control the flow of things using those variables. That especially comes in play when we do loops and stuff like that, okay? All right, so declaring a variable, okay? Like I said, we use the declare keyword. And then we give the variable a name. In SQL, all of the variables start with an @ sign, okay? So you're going to do @ and then the name of it. It is a good convention to get used to do an @v, okay? And that'll make a little more sense as we go on. But @variable, right? The V is for variable, okay? There are a lot of people who like to do @v and then a data type and then their variable name. So you can see an example there, sort of in the pinkish purple, right? The @v int my var. So that way they know whenever they're looking at stuff that that's an integer variable with whatever it's got in it. I typically don't go that far. I try to keep descriptive variable names that you can tell what's going to be in it, right? Like if I say @v loan amount, I think the loan amount is descriptive enough to tell you that it's going to be a money value or at least a decimal value that's in there, right? So, but if that helps you with your programming, there's certainly nothing wrong with it, and it is a good way to go. Just know that the @v is pretty common, though. Please do that. Okay. Now, after you give it a name, you give it a data type, right? This is very similar to when we were doing tables and you were giving the data types for the columns in the tables, right? So you're saying declare your variable name and then the data type. So declare @v my int var for an integer, or declare @v my variable var car, so on and so forth. Okay. All right, now if we want to assign a variable a value, there's a couple things we want to talk about. First, if you want to initialize that variable with a value at the time that you're creating it, you can do that. You would simply, after you do the data type, do an equals and then give the type that the value that you're wanting to initially assign it, okay? If you don't want to do it that way, or if you're on a really old SQL Server version that doesn't allow you to initialize the variable right off, you can by all means do a set statement right after it. We'll talk about that in a second. Okay. You can also set a variable to be the value of a returned select statement or something. And that's probably when you're going to get your most value out of it, right? Because you're probably wanting it to hold data from something so that you can do something else with it. In this example here, we're saying, select the sum of all the cells amounts so that you can have your total cells stored in a value or in a variable. And then you can go on and do other things with it, right? Okay. Now, if you wanted to set your variable separately from declaring it, here you go, right below, you've got your declare statement, and then you're going to set it in a second line below it, okay? And that's how you're going to set the value for it throughout the rest of your script, okay? You can just keep doing set to reassign it a value again if you need to or you want to, right? Okay, some other examples of printing the value to the screen, stuff like that. All right, now here are different actions that you can take on your variables, all right? It's a little different than with tables and stuff, but obviously you can create and declare your variable. We just talked about that, right? You can assign it an initial value by initializing it. Yep, we talked about that. You can assign it a new value, or in other words, updating the value, right? You can, through doing that set statement, or you can do select, which is done very similarly to that set statement, right? You can see there on the screen in the second example, select @VB = 5, right? It's just in place of the set statement, okay? You can increment or decrement your variables. Now, this is obviously only for numeric values and typically used with integers. And this is the shorthand version of it. You can do plus equals 1, that's going to add 1 to whatever value is already in A. Okay. And then if that made A 1 already, then now it's going to be 2. And then if you do it again, it's going to be 3 and so on. Okay. You can decrement it the exact same way. You're doing minus equals 1. That's going to take 1 off of whatever value is already in there. This only works if you've already got a value in your variables, right? Remember, now, I should have said this. When we declare a variable, if we don't set a value, its default value is null. Okay. In some programming languages, your variables will have default values if you don't set them to anything, right? Like an integer might have a default value of 0. A Boolean might have a default value of false or 0. A date time might have, like the year 1900, January 1 or something, if you don't set anything. But in SQL, if you don't set anything, its value is null. Okay. And so you need to already have a value there to do these things with it. Okay. All right. That third example in the increment decrement is just another way that you could increment, right? That's how you do it the longhand way instead of the shorthand way, but it does the exact same thing. Okay. Now, variables in SQL, you can't destroy them, you can't drop them, you can't undeclare them. You can't get rid of them while your code is running. It just exists until the code runs and then auto gets rid of itself, okay? So there's no cleanup that you need to do, no garbage collection, nothing like that you need to worry about, all right? Now, you can also not redeclare your variable, right? You can't have two variables with the same name, or you can't declare the variable again to try and adjust some parameter of it, maybe like the data type that we're saying in that last row. You can't say my var that's a string, oh yeah, now I want to change it to be an integer and update its data type or do anything like that. Nope. Once you create the variable and its data type, it's just that way through the rest of the way. If you need to do something else, you need to create a new variable and then maybe cast that value into the new variable or something from your old one. Okay. All right, now variable permanence. I already talked about this a little bit for how long it exists, right? That it only exists while your process is running, while your script is running, okay? And then it just sort of auto purges. In SQL, there is no real substitute or equivalence to a global variable that you have access to create and to use, okay? You don't get a permanent variable that you can set. You don't get a global variable. There are some built-in SQL global variables, but you can't adjust those really either. So that's not what we're talking about here. So here are some options that you do have, right? You can certainly create a table and store variables in there, and then you can update the variables, right? You could create a table and then add a row that says, my department's email address, and then have the email address, and then later on you could go select star from my variable table, from my table, and then get the email address from there every time. That would be a way to essentially store a permanent variable, or some monetary value or whatever it is. And honestly, that is your best option. That's why I've got that highlighted there. The rest of these options are pretty subpar and pale in comparison, and in some instances probably wouldn't be possible within our scope of how the company does things, okay? If you had a server that you manage from beginning to end, or if you can convince the DBA team to do some things, then maybe, but I'm still going to step through them real quick, okay? You could create a function or stored procedure and then hard code values into there. I guess that works great if you've got a value that you're going to use that's always the same value forever and always, because you're not going to want to update that stored procedure function to make that happen all the time. But even still, that's probably just not a great way to go. So you can't alter it, you can't do anything. There's another thing called CLR stored procedures. That's what those are. They're out of the scope of this class, really. But really, a CLR stored procedure is where you sort of more or less make an add-on to SQL Server, add functionality through creating your own um, procedures out in another language like C# or something, okay? And then you can attach that to SQL Server. I've done that before where we needed a SQL Server to be able to call APIs and return values without using another process. And so we built a CLR store procedure that could go out and hit APIs and return the value and do things with it within a SQL statement. But really, that's still not going to be a great option. Even if you did that to store your variables, you're talking about probably storing it in a text file somewhere or into another place, maybe even a SharePoint list or something, right? If you're going to go do that, you're probably just building some more logic outside of SQL Server, and that's not going to be in your SQL script, most likely. You could have SQL read environmental variables from the operating system, right? If you've ever been on Windows and you just open a command prompt and type set and hit enter, you'll see what the environmental variables are. They'll list out for you. You could create a variable in there and have it interact, but that's not a super great way. You also aren't guaranteed that that's going to stay there forever, right? And other processes and things could mess with it outside of your SQL stuff. So again, not great. Okay. You could create a constant in a view. Honestly, this is the exact same as doing the function or store procedure option. You're just building a constant into a view. It's still code. You'd still need to go update it if manually in the code, stuff like that, right? Again, I think your best option for storing global variables is to just create a table and store your values in that table and pull them out and put them in and update them as you need them, okay? All right, so let's talk about variable data types. We are not going to badger on this too much. We went on for a really long time during tables, right? And it is not that different in the landscape of variables for what data types you can use and how they function. It is nearly identical, okay? Now, with that said, here is a table, and it will tell you which variable data types are available to variables. Sorry, just data types are available to variables and which data types are available to columns, okay? And which are available to both. You'll see that the ones that you really care about the most, right? Your numbers, your strings, your date times, stuff like that, are all available to both tables and to variables. Now, you have a table variable type, and we're going to talk about that more. I love it so much. But you can't do a table data type inside of a table column, although that sounds like it would be super awesome. I would love that, I think. But you can't do it. So in tables, but you can create tables in variables, right? Same thing with cursors. We won't dive into cursors much, but they help you to grab like a single row of data from a table at a time, like when you're churning through, almost like doing a loop to grab individual values and stuff. You can't do those in tables because they're only really used during runtime of a script, so they're only allowed to variables. Okay. And then row version and identity. Those aren't really data types, but they are use properties that are only available to tables and not to variables, right? You can't set an identity 1-1 on a variable because it's not going to increment. However, going back to talking about the tables, and we'll talk about it more, you could do an identity property on a column within your variable table. That's totally allowed. But you can't use the identity property just on a variable, okay? All right, so moving on. Numeric data types. This is pretty much what you would expect from, the table columns right into variables, right? Same sort of thing. I'm just giving you what it would look like to declare those and to set them, okay? And a little bit of a description of them. Same thing with strings, right? You've got your var car, and your car, and car. Same thing. You're just declaring your name, type, giving a value. Okay. Same thing with date times. again, I'm not going to badger on too much about these. Here are a couple other data types, right? Um, that can be used. We're not going to talk about them really in much depth, but that you can give a variable an XML data type or var binary and stuff. Those would be like if you're storing images or other binary type things in your database, right? Table, we are definitely going to cover that in some later slides. So I'll move on. All right, so variables, you can use them within your query, and probably the cool thing is you can use them in anywhere in your query pretty much. You can use it like in return the value as a column name itself, right, as a data element. You can also use it like in your where clause or your joins, okay? So, that can be super handy, especially if you're working through different, I don't know, in this case, maybe product types, right? You're going through a list of different product types that you want to do something for. You can keep updating the product type and running your query and then having it just apply to that one. And then so on and so forth. Okay. You can also set the value of multiple variables at once. Now, this is where you finally use that select instead of the set, right? You can just do it by doing a comma in the name and then the values, okay? And you can set multiple variables from multiple columns in a table all at once, okay? So you don't have to do them individually. This can help with performance so that you're not, doing 3 SQL statements when one would suffice, right? And so on and so forth. And it keeps your code a little easier to read and stuff. So in this case, you're saying select and your variable name equals the column name from the table, and then your table properties. Now, one thing to note on here is, let's say that I didn't put this prod ID equals 1, this whole where statement. It's going to be kind of up in the air what these values are going to end up with. They're going to be set to whatever the last value was in the table that applied to my select statement, right, into my filter criteria. And so because SQL doesn't have a guaranteed order, if you didn't specify an order by or something, that really doesn't let you know what it's going to be set as. And I only say this because you want to make sure that you write your select statement in a way that's only going to return one row of data, all right? At least the way this is written here, so that you know for certain what is going to be placed into your variables for any given time, okay? All right. Okay, here's some best practices for variables. Make sure, we've already talked about this and in other classes. Use good names, use meaningful names, names that mean something to you, things that mean something to the random person who's never looked at it before that's going to come after you to look at it, right? So that people know what's going on, what it's supposed to represent and be for, okay? Now, different people have different thought processes on where you should declare variables, excuse me. Some people feel like you should throw them all at the very top of your script and declare them all there, and then you just set them as you need them later on. Other people feel like you should declare them right before you're going to use them. I'm not going to tell you what you should do all the time. I will say find an organized way that makes sense and that is consistent, all right? That's probably more important than exactly where. Be consistent. And if you're going to do it where the declarations of them are down further in your code, then please use comments or something so that they kind of show up a little more when somebody's scrolling through, right? So you can see what's happening and stuff. All right. Don't reuse variable names across scopes. That would come in more of like if you're doing dynamic SQL, which we're not covering, or some nested SQL statements and stuff, you can end up with unreliable results. It's just bad. Honestly, at this point, you'll mostly just get errors. So keep everything uniquely named. And then also in the newer and the later versions of SQL that we've got out there now, We've got try cast and try convert for casting or converting data types. We talked about those in our last lesson, right? Um, Use those when you're setting values from other things, especially if you've got a monetary variable and you're pulling a value out of a string. Do the try cast or convert. That way, if it can't do it, at least it sets it to null instead of breaking the whole script, unless you really do want it to break the script. And that is a valid thing, right? Sometimes if you don't get something, you want it to break so that it doesn't keep doing things and break more things. In which case, don't do the tries, just do the cast or convert. But okay, give those a try. All right, so now we are going to talk about tables. And I know there's somebody out here that's saying, dang it, Noah, we already discussed tables for like 3+ hours. Is there really more to tell us about tables? And you're not wrong, but I'm still right. No, I'm just kidding. We do have some more to talk about, okay? We do have some things, especially because now we're talking about different kinds of tables. Before, we pretty much focused on just permanent tables, the ones that reside in our schema, the ones that live in our database full time after we've created them. And now we've moved on to those temporary things, okay? So we're going to talk about what that means for us here. And honestly, for doing long SQL scripts and things, these are kind of amazing. Not all flavors of SQL out there have the ability for the types of tables we're going to talk about. And it is so nice that Microsoft has it in. It can make code so much more readable. It can make it so much more maintainable and understandable. Um, and honestly, in a lot of times, it boosts the performance amazingly and can make it so that you've got way easier troubleshooting steps along the way. I highly suggest you use these, okay? All right, let's get talking about them. Oh, crap. All right, well, first, I guess we've got something else we need to talk about before we can dive into tables. It's okay. Um, but let's change our thinking caps for a second, and we're going to talk about computer memory. All right. And you'll see why this makes sense in just a minute. So hang with me, please. Okay. So we have different types of memory in a computer, and I've picked probably the most common ones here that a lot of people know about and that are thought about when we talk about computer memory. All right. And I've listed them in a specific order. On the top, we've got the ones that are the most temporary, but are also the smallest amount of storage, but they're also the fastest. Okay. But that most temporary is sort of what we're going to dive into the most here, okay? And then on the bottom, we've got the ones that are the most permanent types of storage. They're the slowest and offer the largest amount of storage, right? Okay, so I do want to throw out a real quick caveat here. I'm not talking about virtual memory here. I'm not talking about flash. I'm not talking about ROM, read-only memory, stuff like that. Because I'm trying to illustrate a point. So I know this isn't all the types of memory that we have in a computer. Okay. But on top, we've got registers. Now, these is just a really small amount of memory that exists in a CPU. They are, I don't know, like on a 64-bit CPU, you've got maybe a couple hundred blocks of 64 bits worth of this in a processor. And stuff in here is moving through like lightning fast, faster than lightning, really. I mean, in the time that it takes lightning to flash through, this memory has probably pushed millions of things through it. Okay. I mean, this stuff is super fast. Um, okay. All right. And then next we've got cache memory. Cache is also sitting close to the processor typically. Okay. It's comparative to registers, there's a lot more of it. We've typically probably got, depending on what kind of cache we're talking about, L1, you've got it like 64 kilobytes, usually in that ballpark. L2, you've got like half a megabyte to 2 megabytes typically. L3, you're looking at more like 4 megabytes to 32 megabytes, right? So not huge amounts, but a lot more than registers had. And it's still really fast stuff, okay? And then next up, we've got RAM. right? You guys hear RAM and memory all the time, probably on computers and things, right? We wish we all had more of it in our laptops, absolutely. But um, this is the next one up. And this one, I don't know, work machines, I guess, it's pretty typical to have like 8, 16 gigabytes. Um, out on the market, I think it's not uncommon to see 64 to 128 gigabytes at this point. And for comparison, we're talking about gigabytes now over megabytes, right? And a gigabyte is 1,024 megabytes. So if that cache only had one, we've got thousands of times more, 64,000 times more in our RAM than we have in cache, right? A lot more. Okay. And then we get down to our SSDs and our hard disk drives. Okay. I'm going to sort of talk about those like they're the same for the sake of this. They are our largest storage, right? We're up into the terabytes now, typically at home, a terabyte being 1,024 gigabytes. Okay. So, I mean, these are huge amounts of storage compared to the things above them, right? But they're also comparatively a lot slower, like a lot slower. Okay. All right. So why are we talking about this? I promise we will get there. Now, what I want to have in your mind here for a second is when something near the top of this list gets filled and it has to have more space, it has to push things to the next level of memory, right? So if cache gets full, it has to push the overflow into RAM. If RAM is going to be full, it has to push that overflow into like virtual memory onto your hard drives, okay? And that process is expensive, it's very slow, it's also introduces a lot more calculations to make it happen. And the fact that you've got RAM that's really pretty super fast compared to, say, a hard disk, you've got stuff that's intended for RAM now stored on the hard disk drive. Not only is that hard disk drive a lot slower to pull the stuff out from and put things into, but you've still got the processor effectively hitting the RAM, then getting a address returned back to it to tell it to go get it from the hard disk drive. So you just spend a bunch of time like going back and forth for where do I find this and getting it. Okay. So it makes things tremendously slower when you've got to bounce around like that. It's way more efficient if you know that you're going to always be doing 8.5 gigabytes worth of memory operations on your computer to have at least 9 gigabytes of memory on your computer, right? So that you're not having to page out to the hard drives. And that's the same with the cache moving to the RAM or the registers moving to the cache and so on and so forth, okay? All right, now I want you to keep that concept in your mind because that's going to, weirdly enough, become very relevant to what we're about to talk about. Okay, hopefully you've got that and I haven't lost everybody. Let's do it. All right. Boy, that seemed a lot faster when I practiced it earlier. Okay, we are back to tables. That's what we were talking about, right? Yes, tables. Okay, here we are. All right, so here is a similar table of tables comparing our speed and how temporary and how permanent these tables are, okay? So first up, we've got drive tables. It's not going to take you very long to realize I'm not a fan of drive tables, and especially in Microsoft SQL. They are the shortest lived. They are fast if they are done precisely right, in the right scenarios, in the right way. And guess what? Nobody can do that. So in very, very small snippets, they can be great, but in large. Okay, so conceptually, they're like our registers, but they're like damaged registers that you're almost always going to, because there's not all the registers are available, you're almost always going to have it pushing up to the next level of memory, to the cache and to the RAM and things. And because of that, they become very expensive very quick. And really, at that point, you lost any benefit of using it. Okay. But they are there. And the way you do it is you simply, in your select statement, you write another select statement in your from clause. okay? And then you're able to select the columns that came out of that from, okay? Right, just like you would a table. Okay, now we'll talk more about it in a second. Let's talk about common table expressions, CTEs. Um, these ones are orders of magnitude better. They are still super fast in comparison. In if we were to liken it to our previous chart, they are kind of living in the cache land. Okay, um, there's not a whole lot of space that should be had with them, and if you cross that amount of space, you're going to be dumping into RAM, and so you're going to be getting into some of that slower performance. And if your CT is even that much bigger, by all means, you're going to be paging out to the hard drive. So they can become slower, but they are far less prone to it than the derived tables or our subqueries. And SQL is far more optimized to handle it from CTEs. Okay, so keep that in mind. All right, now variable tables. These are squarely living in our RAM space, which is pretty cool. It is a great place to live. It's still pretty fast. I don't think many of us complain about RAM speeds typically, RAM amounts maybe. Um, and it has orders of magnitude more space to work with before it needs to think about paging out to the hard drive or something. And so it happens far less frequently. Okay. Um, and it persists for longer. Like we've crossed into this space, these first two live very, very short lives um, for just an instant. Okay. Think of that when we talked about the registers before and cache. Boy, like you just blink. I mean, a computer's doing millions of, at this point, billions of operations a second. Um, these two have existed for a blink. They don't stick around. They don't care what's going to happen with the rest of your SQL script. They did their thing and they went away. All right. Okay. But variable tables, we're starting to get into the land of it persists for longer. Okay. So in this case, a variable table persists for the rest of the duration of your SQL script. All right. So you could be doing a whole lot of other things after it. It's going to still exist until the very end of your SQL script. All right. Okay. Now, next up, we've got our temp tables. There's two different types, local and global. Um, they effectively operate the same. It's just the difference is about who can access them. Okay. So they both squarely live on the hard drive, just like any permanent table does. All right. They are actually created in the temp DB, and then that's where you operate out of them out of and stuff. Okay. So if you ever get an error when you're making a temp table that you can't do it, you go to the DBA and tell them that you need to be able to do that and that they need to give you rights to the temp DB to do that. Okay. All right. Now they're slower than the other ones sometimes, right? But if you've got enough storage that's going to happen in your temporary table, whether that's a variable table or an actual temp table, um, that it would fill up the RAM, right? Like you're gathering a lot of data to work with, or you're going to be doing a lot of massaging with it, then you're actually going to be faster putting it in a temp table, even though it's technically quote unquote slower because it lives on the permanent storage, right? But because it's not having to page out, and honestly, like the variable tables, when they get too big, they don't even have to fill up the whole RAM. SQL Server will cap it off at a certain point, and then it will just start dumping it into the temp DB on the hard drive anyway, which is basically paging out to virtual memory in sort of a SQL sort of fashion. Okay. Um, so anyway, picking the right temporary table type for what you think you're expected to do can help the performance of your script tremendously. Okay. All right. Okay. So let's talk about common table expressions, the CTEs. Um, these, I don't know why. I was going to say they're fun, and then I was going to retract that, but you know what? They are. We're just going to call them fun. Okay. All right. So, like I said before, these are super temporary in their results. Okay. Now let's talk about that in a second, but these are fantastic for helping break down what could otherwise be large, gnarly SQL statements and with crazy joins and massagings and things, um, because of how you can break them up, and you can make your codes look so much easier and maintainable and so that people know what's going on. Okay, but they only exist until the SQL statement directly after the last CTE is declared in the chain. Okay, and you'll see what that means in a second. Really, you only get one select statement after them, and then they're gone. So you you could use that select statement to insert those results into another table that sticks around longer, right? Like a variable table or a temp table. Um, but that's as long as you get with the CTE. Okay. Also, CTEs, you can do recursive things, and you'll see what that means in a second. But basically, you can have multiple common table expressions declared in a chain and have them reference each other, at least going up the stack. And that can be super useful for when you're trying to refine things down and down. And then that very final select statement that I mentioned before can reference the very last CTE. It can reference any of them and join them together and stuff. Okay. All right. I think I talked about that. Uh, yep. There are some limitations we want to talk about with CTEs. Okay. Because they're not real tables, you can't specify indexes, you can't specify keys, you can't do identities, you can't do any of the things that SQL Server might normally do with a table to optimize a table. All right. Um, and they are single use, like we've talked about. You get them to that select statement after the group is declared, and that's it. And then they're thrown away. Okay. Um, and like we've talked about before, they're not great for large data sets because they start breaching that amount of storage space that they can get through. Okay. All right. So here is an example of how you could create a CTE, right? You'll notice I've got the semicolon up front here, and then you've got with, and then by naming convention, I always do my CTE tables with a CTE on the front underscore, and then the description of this table, okay? And that's just so that when I'm writing my select statement at the end, I can get to my CTE tables really simply, really clearly, and somebody can look at that statement and know where that data came from and not go looking in the real tables for it and stuff, okay? But here it is. You do a select statement inside of it, and now this has created a CTE that has two columns, one with customer ID and one called total spent, this sum, okay? And then here you can see we did a select statement right after we declared it. And here's our table name, right? And we're there again able to do just things that we would with a normal table. We can do filter criterias with wheres or whatever else, or group bys afterwards, okay? Now, before I carry on, I want to talk about this semicolon on the front here. If you go look up the specs for a CTE, you will not see it say that you have to have a semicolon on the front there. All right. And that's okay. I'm still going to tell you to do it. And here's why. Because the previous statement before you declare a CTE, before that with, does need to be terminated with a semicolon. All right. And if you're not in the habit of always terminating every SQL statement you do with a semicolon, you're going to run into an error that you may or may not understand and that may or may not have been discernible about things not working right. Okay. Newer versions of SQL are doing better at making the error for this more understandable and knowing that, oh, okay, something's wrong with my CTE. I need to go look, the previous statement's not terminated. But it's really just easier to get in the habit of putting a semicolon before with, even if your previous statement was terminated with a semicolon. You haven't heard anything, nothing's broken, you didn't do anything. But that way you always know you have it. It's just a good habit. And then you've got it and you just don't think about it anymore. All right. Okay. Here's a second example, very similar, right? Here is when I was talking about being able to do the recursion or being able to, excuse me, uh, being able to declare several of them in a chain. Here's what I was talking about. So we've still got our semicolon with, and then our first one that we've declared. But then when it's done outside of the parenthesis of it being declared, we can just do a comma and give another CTE name and have it. And you'll notice that this one references the first one, right? So you get the benefit of being able to work with this data set that you've already massaged to sort of massage it again or do whatever you want or that you need to. And this will be a lot more understandable to somebody than a bunch of nested queries and and a bunch of other weird things that you might do outside of it, because we already know just from the name, all right, this is our summary of sales. Cool. Okay, in this one, we are trying to narrow that down to being the top products. And in this one, okay, we got our final results that we used, our top products. And frankly, we could have also done a join and joined it onto some sales summary or something if there was another column from that we wanted to add in, right? And so you can just sort of work with things down in chunks this way in a descriptive and easy thing to follow, all right? And then down here, you'll notice we've got our select from final results, and then it's joining on another actual table that's out in the database, okay, to give us a final result that we want for a report or something, okay? This really is a great tool in the toolbox to have when you're doing stuff with SQL, especially for smaller data sets, okay? Here's some best practices for CTEs. Like I said, I like to do that CTE underscore on the front. It just makes it real easy to know what's going on and to follow those through, okay? You can remember to use these to help simplify what might otherwise be some gnarly logic going on or things like that. If things are getting complex for something else you're doing, come think about a CTE and go, I wonder if I could just do this in multiple steps doing that to help me work through this problem in a simpler way. Okay. Also, make sure you use comments fairly generously. I didn't in this example use them, in part because I've got limited space on a slide here, right? But it probably would have been good to have a comment here up above what I was doing, maybe why, for each one of those CTs, okay? All right, and what the intention of each of those was. If you need to use the logic that you've got in your CTE like multiple times, or the data that you're going to get back from it multiple times, instead of using CTEs, consider using another table type. Like if you know you're going to need this top products stuff more than once, then go ahead and just throw it in another table type, right? That sticks around for longer. Same with all these other ones, okay? All right, now let's talk about derived tables. I think this background here pretty solidly describes how I feel about them. Before I get started, let me give sort of an example from life. In a previous area that I worked, there was somebody who wrote a report, and this report was big. I don't know. It was thousands of lines long. There was all these nested queries. It wasn't really formatted that great. It was a nightmare to work on. It was slow. And this person threw up their hands and didn't want to work it out anymore. And so for some reason, that meant that it needed to come to me. And I would just like weep a little inside every time somebody needed an adjustment or needed me to verify something that was in that report, which was not that uncommon. It was hard to distinguish where the values were getting done, what was going on. And I eventually ended up just rebuilding the whole report using other things like temporary tables and variable tables and CTEs. And the report ran so much faster. It went from like 45 minutes down to like 45 seconds. I mean, there was other enhancements made too, but more importantly, it became a lot easier to troubleshoot and to gather data. And it became because the process became more step based. And so I could grab at some point in the script and tell it to dump out the results at that point and see what had happened between, two different points to see why something might have occurred, right? And so it became a lot more auditable, it ran better. All right, we're still going to talk about drive tables, but I think you've got a sense of how I feel. All right, so what is it? What am I talking about when I say a drive table? Well, in a very simple form, like we said before, you've got your select statement, and then you've essentially got a select statement that is taking place of a table in your from or a join or something, right? And so you have this select statement that its results are essentially the table that gets passed up. Okay. There are some flavors of SQL that are very well optimized, and if you look at their manuals, this is the preferred way to do things. Um, and in Microsoft SQL world, it's not as optimized for this, and for good reason. They've given us other amazing tools. Um, but if you see somebody who's doing it a lot, there's a good chance that they may have come from like an older Oracle background or something, okay, where it was used a lot more and where these other tools weren't available to them. Okay, so here's when it's acceptable to use a derived table. Well, for simple one-off queries, and when I say simple, I mean like the two-liner type simple queries, right? If it's a query you're going to use more than once hour, don't use it. Use one of the others. Do something, all right? You can use it when your performance doesn't matter. You can use it when you're feeling lazy. You can use it when you don't care about those who come after you and you want them to hate you. And that might include yourself. And I'm going to stop right here. If you feel that way about yourself, that you want to harm yourself by using subqueries now, please go talk to the Employee Assistance Program folks. Those people can help you. That program is real. I won't badger on about it. But if you really want to hate yourself by doing this, maybe consider talking to somebody that can help you. All right? Okay. When readability and clarity doesn't matter, when code maintainability doesn't matter, and ultimately when your job doesn't matter or the job you're doing doesn't matter. Okay, those would be acceptable times to use a drive table, subqueries. Here's reasons why not. I don't want to read this. Do you want to read this? No, nobody wants to read this. It's here. You can pause it. You can read it if you really want to. I wrote it. Yay. But let's go ahead and get to the too long, didn't read. Basically, what that all boils down to is friends don't let friends use subqueries, so don't do it. I'm badgering on about it some more. Okay. Here's some best practices for derived queries. First one is use CTEs instead. Second one is use temp tables instead. Third one is use variable tables instead. Fourth is use views instead. Fifth is use regular old tables instead. You've got a lot of options. Use them instead. Okay. All right. Variable tables. Oh man, I love these ones. These are ones that like when people learn it like blows their mind and it's just exciting. I don't know. Maybe it doesn't for you, but maybe hanging around with weird people. But variable tables. Okay, you can think of it as being like a scratch pad, right? That's for a single meeting. They're quick, they're there, but hey, ultimately it's disposable. And as soon as you walk out of that meeting or that session of the meeting, right, it's going to be thrown away. It doesn't exist. So it definitely lives longer than drive tables and CTEs. Now we've got something that can live throughout, but it's still temporary and it still only exists in memory, right? In the RAM, okay? Now you create one by doing declare like you would with another variable, and at and the table name, and then you're going to give the table specifications, and those table specifications are done in the exact same way that you would with a permanent table like we talked about in the previous lessons, all right? So you'll notice, and we'll get to it too later, but my convention for tables is I do @T instead of V, right? Okay. Okay, we already talked about when they exist. Again, these are good for smallish data sets. you can decide what that means. In my mind, I think somewhere between 5 to 10,000 rows, assuming you don't have an insane number of columns. If you have a lot of columns, then it might be less than that, right? But that's about how much I would plan for a variable table before I start thinking about going to a temp table or a regular table. Okay, just sort of estimated wise. No hard rule on that, but that's how I think of it. Okay. All right, now variable tables, here's some limitations on them, in particular compared with full-on tables, right? You can still do a primary key. You can do uniques and other check constraints on them. You can do default values on them just like you would a regular table. You cannot explicitly define an index. You cannot give a variable table an index on any columns. You sort of do end up with indexes as you do the primary key and some of the other constraints. But you can't explicitly say that I want to do this index. And you generally don't see people doing foreign keys. You can't do that either. Okay. All right. There's no statistics kept on it. So any performance benefit that SQL might have from statistic counting on usage for tables and stuff isn't done on variable tables. You also can't do any table hints. The only one we've really talked about so far in this class is this with no lock. There's really no reason to lock a variable table, right? You're the only one using it. It exists just for you while this code runs. There's not going to be anything else locking it besides you. But if you try to do that, you will get an error. SQL will tell you that it can't do it, and you'll have to go remove it before your code will move on. Okay? All right. So here's how you declare a variable table, right? We've got our declare at t, and then our variable name, and then data type of table instead of integer or something, okay, right? But then after that, in parentheses, we're going to give our columns just like we would in declaring columns in a regular table with the data types, okay? And then after that, we can work with it just like we would a table. We can insert into it from another SQL statement. We can insert into it. We could do the values and insert specific values. We can delete rows. We can update rows. You can do whatever you want with the variable table, just like you can think of as a table. In fact, you probably have more rights to this because you have full rights, whereas in full tables, chances are most of the tables you only have read-only access or limited, right? And so if you want to massage data and work with data, this is a great place to do that. Okay. All right, here's some best practices. Again, I like to use the declare at t before the name instead of the at v for, okay. You basically use the same best practices for these as you would for the tables that we've talked about for tables in the previous lessons, right? Help keep better performance, help keep data types proper for each of the columns and as small as will fit what you need. Okay, use them for small scoped. Still declare any keys or constraints you want on them so that SQL still keep track of it, and help you out with that. Avoid doing it for large joins just because the execution plan for the optimizer can't really work with the variable tables in the same way that it does regular tables. So it's not going to be able to give you a huge benefit. But if you're doing a small variable table, I don't know, maybe you got 100 rows or 10 rows or something that's just sort of a lookup type table that you want to join on another table that's got 100,000 rows or 200,000 rows or something, that's fine, right? Your variable table is still small, temp table. You're not going to be hit too hard for that, okay? So don't be too scared, but just keep it in your mind, okay? Again, you can't do indexing. If you're going to do heavy logic behind stuff, if you're looking for better keys, better indexing, you want the system to do a little more performance tuning to it, look to move to the temp tables or a regular table, okay? Like we've said before, use meaningful names for your variables, for your temp tables, everything. I'm going to keep hammering that point just because it's important. Okay. All right. Of course, you want to benchmark. I have seen times where I thought that one type of table was going to perform better than another type, and in logic it should have, but I swapped it out for another one. Like I swapped out, say a temp table for a variable table or vice versa. and ended up getting way better performance than I expected by the swap. So it's always worth. It takes you only a few seconds to really swap them out, right? So for something that could benefit a lot, it's worth checking out in your different use cases. Okay, so now let's talk about temporary tables or temp tables. Okay, like I said, there's two different kinds. We'll sort of talk about them similarly together. There are some couple of slides for the individuals, but for the most part, they are the same. All right, so in comparison to the other ones, you can think of a temp table as being like a whiteboard with shared information during the session running. Now, if it's a local temp table, that means that it is defined by this single hash sign or right before the name. Then it is only available to you in your session of SQL. You can have multiple queries going and they can all access it, but it's really only accessible to you. It's not going to be accessible to somebody else running SQL statements on the same SQL server. Okay, but let's say that you have an automation process, right? And that process makes multiple connections, wants to run queries asynchronously or something, then they absolutely can access it and they can get to it and they can interact with it together separately, right? So that they can do whatever they need to do asynchronously. Maybe they need to, okay? But if that's service account 123, and then there's another service account 234 that connects in with its own session separate, it's not going to be able to access this temp table. All right. Okay. They are physically stored in TempDB on the hard drives. They do support pretty much everything that a regular table supports: indexes, constraints, statistics. Okay. And they essentially live. I said that they live until your session ends, right? And that's true. But also, unlike variable tables, you can drop them. You can do a drop table statement just like you would with a regular table. Variable tables, you can't really. Once you've declared it, you've declared it. The most you could do is empty out the data out of all of it if you wanted to, okay? To shrink it up its memory footprint if you're not going to use it for the rest of your script. But for these temp tables, they will exist until your sessions have ended or until you drop them, right? It's pretty common when you have a script with temp tables at the end of the script to do drop statements for your temp tables, just to make sure that those get cleared out so that if you rerun your script to check something, that you don't get errors when it tries to recreate them or something. But, okay. So these are great tools. Yeah. Let's talk a little bit more about it. Here's an example. You create the table just like you would a regular table now, except for you use the sharp or hash or whatever you want to call it in front of the table name. Okay, and that's what tells SQL that this is a temp table. Okay, and then you define it just like you would, and otherwise you just work with it like you would anywhere else and stuff. All right, now let's talk about global temp tables. These are defined by having two of the pound signs, hash signs, sharp signs, whatever you want to call them. Okay. And these have a larger scope of access, right? So that means that, your service account 123 created it and is using it, and you've got another service account 234. It can get to it, and they can both be interacting with it and doing stuff. They can both see it. They can both inserts and updates and deletes and whatever else they might need to do, select data from it. Now, service account 123 created the table, and with a local temp table, when he disconnected and no longer existed, that temp table would have been auto-purged from SQL. It would have dropped it. But in this global sense, if service account 123 disconnects and then service account 234 is still using that table, the temp table will still continue to exist for as long as that service account is using it and has references to it. But as soon as SQL Server can tell that nobody else is looking at that table anymore, it's going to drop it. Okay, so it exists in a broader sense. Also, be mindful that if you do something as a global temp table, because other sessions can access it, be thinking in your head of how sensitive the information is that you're putting into it versus what other things and other people that might have access could do with it if they know about it and when it's running. Okay, so there's a security thought there about it. Probably generally not an issue, but still there in the back of your head. Okay. All right. Now let's talk about permanent tables. I know, we already had like 2 or 3 classes on these. I'm not going to hit it too hard. You guys already know everything there is to know about it and are doing awesome. So just a refresher, right? You create the table and give it the names. This is exactly like those temp tables, but without the little hash sign in front of it, okay? That's really the biggest thing here. Everything else is the same, okay? And when it exists. All right, here is a table that compares all those different table types with some different information to give you to think about on it, the syntax, how reusable they are, if they support recursion, what some examples of when they're best for, and stuff like that. Feel free to give this a look. I'll include it in the handout that I send out, when I send out the slide decks. But here you go. All right. Okay. Now next up is queries. Right. I think I already told you at the beginning of this, we weren't going to hit on this during this class. We're going to hold these off to talk about a little bit as we talk about programming stuff in the next class, just because they seem to fit better in with that material and because I don't want you falling asleep. I want you to be able to remember some of this stuff. Okay. All right. Here's a quick glossary of terms. If some of the words that I was using didn't make sense, hopefully I described them along the way, but here's those. And that's it, folks. Hey, thanks for making it to the end and for watching this presentation. I hope you guys know how awesome I think you're doing in this class. I know that I don't do a lot of homework for this and stuff because we've all got jobs and things going on. But you need to know one thing. You need to know how much I hate recording myself. I hate it way more than presenting in person or even through Teams or something. I don't even record messages for my family. Like, I just don't like it. So if I didn't think you guys were awesome, I wouldn't be doing this. Anyway, thanks for making it to the end, and I hope we can talk to you later. Again, reach out to me if you have any questions or problems. If you want me to review this material again, I'm happy to do that. I'm happy to go through this with a group of you or even individually. And all right, we'll talk to you later. Bye.